Good evening, guys. So, this is a lesson for August 20th, 2020. This is lesson 2-3, solving more complex equations. So, our learning targets here are to solve complex equations with variables on both sides and justify each step in the solution process. And then write and solve an equation to model a real world situation. So, you guys have heard of PEMDAS. It's a way of making sure that you understand the steps that you need to take when you are doing basic operations. Well, to help with solving complex equations like we're going to be dealing with today, think of the phrase, "Don't call me after midnight, sir." So this phrase can help keep the steps to solve an equation in order. So the first step you're going to take is don't, which is distributive property. So that's when you have a term on the outside of the parentheses and you need to distribute it to everything on the inside of the parentheses. Then call, combine like terms. That's after you distribute everything. Me is move variables one direction and constants the other direction. So what that means is if I have a variable, the x variable on both sides of the equation, I need to get those together on one side. And then I need to move my constants the opposite direction of whichever direction I move my variables. After is addition and subtraction properties of equality whenever needed. And then midnight is multiplication and division properties of equality. And then sir is where we simplify our solution and we have our answer. So that's just a little phrase to help kind of keep the steps in order. You can always come back to this video. I can always just share this specific slide with you guys if you want. So you have it. So you have that phrase to keep your steps in line. So let's talk about an equation. So let's look at this equation. It's solved for you on the next slide. So you're going to complete the table by stating a property or explanation for each step. Math tip: if an equation includes the product of the number and an expression in parentheses, you can simplify it by applying the distributive property. So you see that you have a set of parentheses, so you would use the distributive property. You would distribute this -2 onto the x, and then the -2 onto the +3. But it's already solved for you, so we don't have to worry about that. So I'm going to go to the next slide. You're going to pause it and take a couple of minutes to get an answer, and then you're going to unpause it, and we're going to talk about each of the steps. So we have the original equation first. Then, like I said in the previous slide, you're going to do the distributive property. You're going to distribute that -2 onto the x plus 3, and you'll be left with 3x minus 2x minus 6 equals 5 minus 2x. So when you combine your like terms, you have x minus 6 equals 5 minus 2x. Then the next step you're going to take is the addition property of equality, or I took the addition property of equality. I added 2x on both sides. So when I simplify and combine like terms, I'm going to have 3x minus 6 equals 5. Then I'm going to use the addition property of equality again, and I'm going to add 6 on both sides. And I'm going to have 3x minus 6 plus 6 equals 5 plus 6. And I combine my like terms, and I have 3x minus 11. Then the last step I'm going to take is I'm going to divide both sides by 3. Remember that the whole purpose of solving an equation is to isolate the variable all by itself on one side of the equal sign and move everything else the other direction. So I needed to divide both sides by 3 here in order to get my x by itself. So when I simplify that, I have the solution x equals 3 2/3. So you are going to solve the equations below, taking the steps you need to solve them. You're gonna pause the video. You're gonna solve the equations. We'll talk briefly about different properties that you're going to take to answer these questions, but I'm not going to spend a whole lot of time going through every single problem. So make sure that you feel comfortable with solving equations. And this is just some extra practice for you to do. So you're going to pause this video, you're going to write these down, you're going to work on them, and then you're going to come and see the answers. So the answers are x equals negative 11 halves for A, B, y equals 5 fourths, C, p equals 9 tenths, and D, a equals 5. Do not be afraid of fractions. I know that fractions can be a frustrating thing to deal with, but don't be afraid of fractions. They aren't numbers that aren't real or aren't appropriate. If you ever solve an equation and you get a fraction, don't be worried about the fact that, oh, did I do it wrong? Because more likely than not, you probably did it right. Most equations that we solve in the next few weeks will actually have fractions as answers instead of whole numbers. Now, there will be some whole number answers, but there's going to be a lot of fraction answers too. So it's not going to be oh, did I do this wrong? I'm supposed to only have whole numbers. So don't worry about doing it wrong if you get a fraction as your answer. So I'm going to go over B specifically. So you have 2 times 4y plus 3 equals 16. I'm going to use the distributive property. And I'm going to distribute 2 onto 4y and 2 onto 6. 2 times 4y, that's 8y. 2 times 3 is 6, leaves me with 16. And then I'm going to use the subtraction property of equality, and I'm going to subtract 6 on both sides. I've got 8y on the left, and then I have 10 on the right. Now the last thing I'm doing is I'm dividing by 8 on both sides. Y equals 10 eighths. But this is a fraction that can be simplified because the top and bottom are both divisible by 2. So it's actually y equals 5 fourths. Okay? So now we're talking about steps that we took. In that one, I used the distributive property, the subtraction property of equality, and I used the division property of equality because I divided both sides by 8. So I used the subtraction, distributive, and the division property of equality. If you did the others and you did them correctly, you probably used all 5 of these properties throughout the 4 questions. So what you're going to do now is you're going to create a complex equation within a real-world situation. It says bags of maple granola cost $2 more than bags of apple granola. The owner of a restaurant ordered 6 bags of maple granola and 5 bags of apple granola. The total cost of the order was $56. Let M represent the cost of a bag of maple granola. Write an expression for the cost of 6 bags of maple granola. So the information I have here, maple granola is $2 more than bags of apple granola, and we bought 6 bags of maple and 5 bags of apple, and the total cost was $56. So if M represents the cost of a bag of maple granola, and we need to write an expression for the cost of 6 of them, I'm going to take the cost of 1 bag, and I'm going to multiply it by 6, and I'm going to have 6M. So now I'm going to use the variable M to write an expression for the cost of a bag of apple granola. Well, I know maple granola is $2 more. So if I take the cost of 1 bag of maple granola, M, and subtract $2, I'll have the cost of a bag of apple granola. So now I'm going to write an expression for the cost of 5 bags of apple granola. Well, M minus 2 is an expression for 1 bag, so I'm going to simply multiply that expression by 5. Then the next steps I'm going to take is I'm going to write an equation to show that the cost of 6 bags of maple granola and 5 bags of apple granola was $56. So I've got to add them together. I've got to add maple plus apple and total $56. So I know that 6M represents the cost of my maple, and 5 times M minus 2 represents the cost of my apple granola, and everything totals $56. When I solve this, I need to use the distributive property. 5 times M, 5 times negative 2. I have 6M plus 5M minus 10 equals 56. Then I'm going to combine my like terms. 6m plus 5m is 11m minus 10 equals 56. Then I'm going to use the addition property of equality, add 10 on both sides. Cancels out. I'm going to have 11m equals 66. Then I'm going to divide by 11 on both sides. And I'm going to have m equals 6. So maple granola costs $6. Maple cost $6. And I know that maple granola costs $2 more than apple granola. So $6 is $2 more than apple granola. So 6 minus 2 is going to be $4. Okay? So we see that. So that's how we're creating complex equations. We're breaking down the information we have given the context and variables that they ask us to use. And we're creating the parts of the equation, and then we put it all together to solve. And you see your answers are here. So we're not going to do this right now. But your exit ticket is going to look back at the granola situation. How much would the cost of a bag of maple of each type of granola change if the total changed from $56 to $67? So you're going to take those parts that we put together and you're going to total it equal to $67, and you're going to solve how much it costs for one bag of maple and how much it costs for one bag of apple. So that's what you're going to do. You're going to take the parts that we already made. You're going to create your equation. And you're going to solve it. And remember, m equals maple. And then you'll still have to subtract $2 from that to equal apple. And then you're going to get your answers over here. And you're going to input your answers into the Schoology exit ticket. So if you have any other questions for me, don't hesitate to email me. Remember, I'm available from 7 a.m. to 6 p.m. Monday through Friday. I don't respond on the weekends, so if you need to talk to me, make sure it's during those times, 7 a.m. to 6 p.m. Monday through Friday. And then I have office hours Thursdays and Wednesdays from 7:30 a.m. to 8:10 a.m. And that Google Meet link is in your update section of Schoology. You guys have a wonderful rest of your day and happy learning.